Okay, you guys, for concept 2, we're going to be doing something that is just so awesome that we can tell this from math. People say all the time, how can we tell how are we ever going to use this in real life? Well, this is one of those things that's really kind of cool because you can tell if something will work or not with math, so I don't know. I like it. Here's the thing. Every once in a while, you have a graph, and on that graph, you have a line. We've been talking about this, so this is no big news to you, right? Lines on a coordinate grid is not a new thing. But here's what you got to remember. There are points all over the place on that coordinate grid, everywhere. There's points that are on the line itself that make up the line, points that we probably used to graph the line, right? And then there are points way out here somewhere, okay? Out swimming with the sharks, out in the dangerous waters. They're not holding on to the line of safety, okay? So sometimes we need to be able to tell, is a particular point on the line or off the line? Kind of like when you go on a road trip and you're taking a road, maybe you're taking 95 or taking I-75 all the way up to Tennessee or something like that. And you want to find out if a particular stop is on that road or if it's off on another road. So algebraically, here's what you do to figure that out. What you're going to do is you're going to take an ordered pair. Remember, an ordered pair has an x value and a y value. It has both. You're going to take that ordered pair and you're going to plug it into an equation. If you plug in an ordered pair and you end up with a true statement, something like 3 equals 3 or negative 12 equals negative 12. It doesn't really matter what the numbers are as long as it's true. And you can read it and go, yep, that is true. Then that means the point, the coordinate point that you plugged in, is on the line. We say that it lies on the line. And sometimes it does lie on the line and you get a true statement. And sometimes it doesn't lie on the line and you don't get a true statement. Let's take a look at what we're talking about here. This question asks us, which point lies on the line represented by the equation 2x plus 3y equals negative 6. And we have these 4 options here, A, B, C, or D. Now, just by looking at it, you can't really tell. But if we follow our steps from before, we plug in our ordered pair to see if it's true or not, we should be able to find out if yes, it's true, and it is on the line, or no, it's not true, and it's not on the line. So let's take a look. Starting out with our equation, we have 2 times x, so 2 times something, and I'm going to leave a blank, plus 3 times y, plus 3y, equals negative 6, equals negative 6. Notice I wrote out my whole equation, but I left spaces for my x and y value. That's because I'm going to plug in. So plug in 2 for x and negative 2 for y, because remember in an ordered pair, the first value is x, the second value is y. So we're going to plug those into our equation, and now we're just going to solve it, or simplify. So we've got 2 times 2 is 4. A positive 3 times a negative 2 is negative 6, and this is equal to negative 6. 4 minus 6 is negative 2 equals negative 6. Negative 2 equals negative 6. That's not true. It does not equal negative 6. No, this is not on the line. That's how you would answer that one, or how you would mark that no, it does not lie on the line. Let's take a look at point B. Again, we have 2 times x plus 3 times y equals negative 6. Let's see if this time, when we plug our values in, I'm just going to put in my x to my space, my y to my space. When we plug those in, does it come out to be true? Well, 2 times negative 1 is negative 2. Positive 3 times 2 is positive 6. Uh-oh. Things aren't going too well. Negative 2 plus 6 is 4. And that does not equal negative 6. So no, this point does not work. It is not on the line. It is out swimming with the sharks, and we are not interested in those kinds of craziness. So let's try C. We've got 2 times x plus 3 times y equals negative 6. Plug in our values. X is 0, so that goes in the x spot. y is 2. That goes in the y spot. And now we're just going to simplify. 2 times 0 is 0. 3 times 2 is 6. Equals negative 6. So I've got positive 6 equals negative 6. Very close, but positive 6 does not equal negative 6. So I'm going to draw a line through my equal sign. And this is a no, not on the line. So since this is a multiple choice question, I'm guessing that this one's going to be yes. But since I'm a really smart math student, I'm going to make sure that I verify that using algebra before I just answer. So let's see, 2 times x plus 3 times y equals negative 6. Plug in x in the x spot, y in the y spot. And I've got negative 6 plus 0 equals negative 6. Negative 6 equals negative 6. Yes! This works! Woohoo! So D is the point that lies on the line that is made by this equation. Why don't you take a look at number 8? Pause the video, give it a try, come on back. All right, you should have gotten that one worked. I hope it didn't trip you up that the y was over here by itself, because as long as you follow the same steps, it'll work in the exact same way. You leave a space for y, you leave a space for x, and then you plug in x and y from your point. No matter where they are, no matter what it looks like, just leave a space and then plug them in. Then you'll be able to simplify, I promise. Let's take a look at number 10. So I've got a space for y equals 3 times x plus 1. Just left a space. Now in my coordinate point, the first one is x, second one is y. So I'm just going to plug the y value, which is 5, right in here for my y space, and then my negative 2 into my teeny tiny little x space. Okay, so let's see. I've got 5 equals 3 times negative 2 is negative 6 plus 1. 5 equals negative 5. No, it does not. I draw a line through the equal sign, and no, this does not lie on the line. Make sure that you answer these in yes or no. All right, ready to try again? Pause the video, tackle number 12. Come on back when you think you've got it. Nope, doesn't lie on the line. It was pretty close, but not quite. So, hope you got that one right. Let's do number 15 together, because this one throws you a curveball, and I just want to give you a heads up that sometimes this will happen. All right, so we're going to do a space for x minus 2 times a space for y equals 8. So far, so good. Our point, we have x and y. But notice that our y is a decimal point. I would like for you to change that into a fraction. 0.5 is 1/2. So when you plug it back in, for the x, you plug in 9, no problem. Minus 2, for the y, plug in 1/2 instead of 0.5. Okay? Because I really want you to get more comfortable with fractions. So I want you to use fractions whenever possible. And for these, it's totally possible to use your fraction. All right, so let's take a look. Here we're just going to have 9. Then we have negative 2 times 1/2. Well, how do we multiply fractions? Off to the side somewhere, you can do 2 times 1/2. Now, fractions are finicky. They will only play with fractions, okay? If you're a whole number, forget it. You're not in our club. But the cool thing is any whole number can quickly be turned into a fraction if you remember that the denominator is 1. Okay, so now we have 2 over 1 times 1/2, and now we can actually do that operation together with the two of them. Multiplying fractions is very easy. All you have to do is multiply straight across. Do you remember that rhyme from the first 9 weeks? Holy moly, that was so long ago. But it's the same rule even now. So multiply straight across. 2 times 1 is 2. 1 times 2 is 2. 2 over 2 is 1. So there you go. 2 times 1/2 is just 1. So minus 1 equals 8. 9 minus 1 is 8. That does equal 8. So yes, this lies on the line. Woo! All right, number 13 has a fraction in it too. So why don't you pause the video and give that one a try. Come on back when you're ready to compare notes. Let's multiply that fraction off to the side, shall we? Yay! Both of our fraction problems worked out. That makes me so happy. Why don't you tackle the rest of these problems before you come to class? And remember, if you have any questions, just circle the problem or put a star by it, and I'll be happy to help you out with it the next time we get together.